So good day, sir. Good day, sir. So I am going to report the chapter 5 of the Bushong, which is the X-ray imaging system. So in this chapter, we are going to identify the components of the X-ray imaging system and explain the operation of high voltage generator, relate the differences on single phase, three phase, and high frequency power, and many more. So let's proceed. So in radiology, we have different types of X-ray imaging systems: the radiographic or fluoroscopic, the mobile C-arm unit, and others. So kanang mga ginahigdaan sa mga patient and every radiographic equipment or any radiographic machines is ginatawag siya nga carbon fiber couches. So it contributes to reduce patient radiation dose. So gina-reduce niya ang katong mga radiation dose nga possible maadto sa patient. So kaning mga couches is naka-float na siya o dali ra pod siya ma-unlock sa mga radtech and motor driven. So sa fluoroscopic nga couch is matilt siya like 90 degrees to the foot side and 30 degrees to the head side. So in every X-ray imaging systems na ay three principal parts: ang X-ray tube, ang operating console, and high voltage generator. So kaning operating console is mao ni siya ang nag-allow sa mga radtech to control the X-ray tube current and voltage so that the useful X-ray beam is in proper quantity and quality. So the radiation quantity is X-ray intensity, and the radiation quality is the X-ray penetrability. So kaning radiation quantity is naga-refer ni siya to the number of X-rays in an X-ray beam, and kaning radiation quantity is usually expressed in milligray or milliampere seconds. And the radiation quality is refers to the energy of the X-ray beam, and it's expressed in kilovolt peak, or more precisely half value layer. So let's proceed to the auto transformer. It has a single winding and is designed to supply a precise voltage to the filament circuit and to the high voltage circuit of the X-ray imaging system. So we have auto transformer law, which is the V sub S over V sub P equals N sub S equals over N sub P, where V sub P is the primary voltage, the V sub S is the secondary voltage, and the N sub P is the number of windings enclosed by primary connections, and N sub S is the number of windings enclosed by secondary connections. So let's proceed to the adjustment of kilovolt peak. So KVP is determine the quality of X-ray beam. So and we also have the KVP meter. It is placed across the output terminals of the auto transformer, and we also have the pre-reading KVP meter. So it allows the voltage to monitor be monitored before an exposure. So we have thermionic emission. It is the release of electrons from a heated filament, and we also have filament circuit. It is an X-ray tube current that is controlled through a separate circuit. So the product of X-ray tube current and exposure time is MAS, which is also electrostatic charge. So let's proceed to exposure timers. So we have guard timer. It terminates an exposure after a prescribed time. So usually approximately 6 seconds. So we have four types of timing circuits. First is the synchronous timer. Next is the electronic timers, and the MAS timers, and the automatic exposure control. So those are the four types of timing circuits. So in synchronous timer, there are 60 revolution per seconds. So in electronic timers, it allows a wide range of time intervals. And so in MAS timers, it is usually designed to provide the highest safe tube current, and it is used on falling load capacitor discharge imaging system. And lastly is the automatic exposure control. It is a device that measures the quantity of radiation that reaches the image receptors. So most exposure timers are electronic and are controlled by a microprocessor. So high voltage generator is, there are three primary parts: the high voltage transformer, the filament transformer, and the rectifiers. So the high voltage transformer is a step-up transformer. So the primary voltage is measured in volts, then the secondary voltage is measured in